Well, I would like to start by thanking you for taking the time to attend today's presentation. My name is Lance Zurich, and I am the product manager for the fischertechnik Education Division over here at Studica. And of course, today we're going to provide you with an overview of fischertechnik's line of pre-assembled industrial simulation and training models, including the very latest models incorporating new cutting-edge technologies. I think they're pretty cool. We're going to show you those in just a second here. And one more technical thing I have to deal with, so just bear with me a second. All right, much better. Okay, so we're going to start out. Now, over the years, I would typically begin these presentations and talk about the importance of STEM education, talk about changes in the manufacturing environment, and in general, the growing need for highly skilled workers in the modern workforce. But I think at this point, it's really been pretty well established just why technology-focused education is so necessary. And with that in mind, I'm going to dispense with any preamble, and we're pretty much going to jump right into this discussion of what fischertechnik is, and then we're going to walk through and look at each of the current models in the simulation model family. So fischertechnik simulation models have been designed with the intent of providing a compact, engaging, and hands-on method for teaching and demonstrating high-end automated systems. The line of fischertechnik models consists of a series of pre-assembled small-scale models which are designed to replicate in both appearance and in function various automated robotic machines and systems that are commonly used in commercial manufacturing. Now, before we begin to look at each of these models, let me just provide you with a little bit of background. Fischertechnik has been creating tools for teaching students of all ages how technology works for over 50 years, all based around their unique building system. Now, what makes this building system so unique is that unlike a lot of other popular construction sets where the components are designed to simply stack, in the fischertechnik system, well, it was essentially really created with more of an engineering mindset. And because of that, the core building block in the system is designed to enable attachment from all 6 sides. And with this, it allows for almost limitless design possibilities. Many of the parts in the system are designed to slide together and lock in place using a tongue and groove assembly method. And the hundreds of different parts available also help technical builders to address very specific design needs. The fischertechnik system itself was created back in the 1960s by German inventor Arthur Fischer, who's noted for countless innovations used in the construction and automotive industries. Now, Mr. Fischer, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, prior to creating fischertechnik, Mr. Fischer was first noted as the inventor of synchronized flash photography. This was back in 1949. And a few years later, he gained fame as the creator of the expanding nylon wall plug, which is using in junction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fischer Group, continues to employ thousands of workers all around the globe, producing many variations of fastening devices used in building construction. And they also produce components used in the automobile assembly industry, as well as providing consulting services to companies who wish to employ state-of-the-art manufacturing processes. Now, once again, the focus of fischertechnik building sets, and that's whether we're talking about the sets that are intended for the retail market or for classroom use, in either case, the focus has always been on helping to foster an understanding of technology. Many of the products offered by fischertechnik, specifically for the education sector, are what we would call subject focus sets, and they focus on different STEM-related topic areas, things like mechanics, pneumatics, robotics, as we're going to be looking at today, or renewable energy. Now, many of these sets will either include curriculum or detailed teaching and activity materials, and in most cases, when you're working with the sets, students are asked to build a progression of models using the unique fischertechnik building system. And then as they're working with these models, perform various experiments which allow them to both explore and understand key aspects of the subject being studied. So that all said, the line of fischertechnik simulation solutions, which of course are the focus of today's presentation, are again something much different. This line consists not of kits, but again, of a series of pre-assembled small-scale models which replicate in appearance and function various automated robotic machines and systems. Now, some of the models you're going to encounter in the fischertechnik simulation line will include things like conveyor belts, punching machines, 3-axis pick-and-place robotic arms, color sorting lines, and even a high bay warehouse storage system. Now, besides these individual models, which of course focus on specific automated processes or areas, fischertechnik also offers many variations on an integrated factory simulation model. Now, in these factory simulation models, typically you'll have four or more workstations put together. Most often you'll see a vacuum gripper robot, a high bay storage warehouse, a multi-processing station with an oven, and a sorting line with color detection put together so that they will all work together as one self-contained material cycle. And of course, we're going to look at some of these different factory models as the presentation goes on. Now, before we do that, we're going to very briefly outline some of the advantages of using the fischertechnik system. First, fischertechnik simulation solutions will allow educators to offer engaging, hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this can be for understanding how automated systems work, or for having a tangible physical system to observe and work with in a programming or PLC-focused learning environment. The models, once again, are designed to realistically replicate both in appearance and function common automated systems, things such as conveyor belts, sorting machines, robotic arms, and much more. Because the models are compact, and in most cases we're talking about tabletop-size models, they're not only ideal for use in the classroom or in office demonstrations, but also they're ideal for demonstrating software or other technology-based offerings in a trade show environment. The next aspect is quality. Each fischertechnik simulation model is a hand-assembled, high-quality, German-made product. Each model is available in a 24-volt version for industrial users, with select models also available in a 9-volt version for those not versed in or focused on the use of PLCs. The 24-volt versions are designed for use with industry standard PLCs. Now, it doesn't matter whether you use Allen Bradley controllers, if you prefer Siemens controllers, or if you use controllers from manufacturers such as Honeywell, Mitsubishi, General Electric, or you could probably name many others. In most cases, you can control these 24-volt models using the PLC you prefer. Likewise, just as you can use your choice of controller, you can also use your preferred programming language from the languages that are listed on the screen right now. Now, please note that with these 24-volt versions, in most cases, unless explicitly stated, no PLC is included, and all programming and programming guidance, as well as any power sources, wiring, or other hardware, are considered the responsibility of the end user. Of course, this should not be an issue, as again, these 24-volt models are designed specifically for industrial users or for those teaching or exploring industrial processes involving PLC programming. Now, as I touched on before, there were also 9-volt versions available of select models. In the case of these 9-volt versions, they will ship pre-wired to fischertechnik's own proprietary robotic controller, which is known as the Robotics TXT controller. And in the case of these models, the 9-volt models, each controller is pre-programmed, either using fischertechnik's own RoboPro programming software, or in some cases, C++. Now, the only additional component required with the 9-volt models that we talk about will be the addition of one or more 120-volt power adapters, and I will specify that, of course, as we get to the discussion of models. Otherwise, in most cases, you can think of these 9-volt models as essentially being ready to use out of the box. Now, if you're involved in demonstrating or exploring IoT, which is, of course, the Internet of Things, besides the fact that many end users have adapted many of the models in the primary line of simulation and training solutions specifically for IoT purposes, now fischertechnik also offers a few special IoT-focused versions of the factory simulation, which are designed specifically for exploring and understanding cloud control and what is sometimes referred to as Factory 4.0. In the case of these models, they're designed to be both controlled and monitored from a special web-based dashboard. And of course, we're going to discuss all of this in more detail just a little bit later in the presentation. Finally, fischertechnik simulation models are cost-effective. Now, if you've had the opportunity to look into any of the other hardware-based industrial simulation options that are available in the marketplace, You'll probably notice that the entry point for many of these products can easily be $30,000 to $40,000 or even much more. Fischer-Technic simulation solutions, on the other hand, start at just a fraction of that price. Again, these are compact, realistic, and high-quality learning and demonstration tools. So on that note, we're going to begin looking at each of the models that are available. Now, we're going to begin with a look at some of the more basic modules, and we're going to work our way up to the more involved models, the larger factory models, what have you, which again consist of several individual workstations designed to showcase an entire production cycle. But again, we're going to work our way up there, and we're going to start off with the classic line of Fischer-Technic simulation models. And the first one we're going to look at is a conveyor belt, basic conveyor belt. And this is a transport belt with a length of 275 millimeters that's used to transport work pieces with a diameter of up to 29 millimeters. Now, in the case of a conveyor belt, multiple conveyors can easily be connected to increase the length of transport as you might desire. Components on this model will include an excess motor, a push-button limit switch, 2 photo transistors, and 2 LED light barriers. And I will mention the components throughout, just because I know a lot of teachers we work with, what have you, like to know what kind of modules, what kind of components they're going to be working with as far as for programming and what have you. So I always like to highlight it. Continuing on, the dimensions on this model are approximately 14 by 10 by 4 inches. It has a weight of only about 2 pounds. And this model is available in both the 24-volt version with a multi-pin connector, which will be 26 pins with a 2.54 millimeter grid as shown in this photo. And again, the 24-volt version of this model, as well as all but a few of the 24-volt versions we're going to look at this afternoon, will require you to provide the PLC and the programming. And there is also a 9-volt version, which is connected to a pre-programmed robotics TXT controller, as shown in this picture. One 120-volt power adapter is required for this model. And I will mention that for this and for all the models we're going to look at today, the specs are also detailed on the product listing pages found on both the Studica and the fischertechnik.biz web pages, as well as in our product brochure, which I will provide information on obtaining at the end of this presentation. So I'm going to give you an email address at the end of the presentation. If you'd like to see the full brochure for these models, gets into all the specs, you can just email us and we'll send you off a PDF copy of that right away, or a physical copy if need be. Now, the next model we're looking at, the punching machine with conveyor belt, is a variation on the conveyor belt we just looked at, except this time with a machining station built in. Components on this model include 2 excess motors, 2 push-button limit switches, 2 photo transistors, and 2 LED light barriers. The dimensions of the model are approximately 15 by 12 by 7.5 inches, and it has a weight of just about 3.5 pounds. Again, it's available in a 24-volt variation with a 26-pin connector, 2.54 millimeter grid, as shown here, and the 9-volt version wired to the robotics TXT controller, which again requires one 120-volt power adapter for use. The next model is the indexed line with 2 machining stations. And this model features a U-shaped conveyor line consisting of a milling and a drilling station along with 4 conveyor belt sections. Other components on this particular model include 8 excess motors, 4 push-button limit switches, 5 photo transistors, and 5 LED light barriers. The dimensions are approximately 19 by 18 by 11 inches. It has a weight of just about 8 pounds. It's available in both the 24-volt version with the 26-pin connector and a 2.54 millimeter grid for use with the PLC, and a 9-volt version wired to the pre-programmed robotics TXT controller, and again requiring, actually in this case, requiring 2 120-volt power adapters. The next variation we're going to be looking at is pick-and-place robot, the 3D or 3-axis robot. The 3-axis robot has gripping forceps, which it uses to help it quickly and precisely position the work pieces it picks up in 3-dimensional space. The degrees of freedom for the robot are as follows. Axis 1 turns 180 degrees. Axis 2 can move forward or back 90 millimeters, and Axis 3 can raise or lower 150 millimeters. Components on this model include 2 excess motors, 2 encoder motors, and 4 push-button limit switches. And the dimensions are approximately 19 by 16 by 9 inches, and it has a weight of just about 6 pounds. And now, as with the other models we've looked at, this is again available in both a 24-volt version, again with that 26-pin connector and 2.54 millimeter grid, designed for use with the PLC and the programming of your choice, or a 9-volt version wired to a pre-programmed robotics TXT controller, and again requiring one 120-volt power adapter. Next up, and now we're going to start getting into some video of the model, so you just don't have to look at the still photos. We're going to look at the vacuum gripper robot. And what you're going to be seeing here is the vacuum gripper is a 3-axis robotic model with a vacuum gripping device. Again, this model is designed to precisely pick up and position workpieces in 3-dimensional space. The model includes 3 encoder motors, 3 push-button limit switches, a vacuum suction device, a compressor, and a solenoid valve. So, of course, this is a variation on the 3D robot we saw a little while ago. The dimensions on this model are approximately 9 by 19 by 15 inches. It has a weight of about 7 pounds. And it's available in a 24-volt version. And again, the 24-volt version of this model, as well as all of the 24-volt models that we're going to be looking at moving forward in the presentation, these will each have a relay board for motor polarity reversal in both a multi-pin connector, this time 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, this 24-volt model, as well as all the 24-volt versions we're going to be looking at, will require you to provide the PLC and the programming. We'll let this play through. I will mention as we move through the presentation that as I'm kind of, in general, trying to keep things on moving along, but if you do have any questions, feel free to use the webinar chat window or the question and answer window. You can just type in whatever questions you have. In most cases, I'll address them at the very end of the presentation, but yeah, if you do have anything that comes up, please just type in one of those windows and we'll be happy to take care of that. And there we go. Now, the next model we're going to look at is the automated high bay warehouse. The model you're going to be seeing here features a transfer station with a conveyor belt, along with a shelf stacking mechanism for storing and retrieving workpiece carrier trays and 9 individual storage spots. Components on this model include 2 encoder motors, 2 mini motors, 4 push button limit switches, 2 photo transistors, 2 LED light barriers, along with a selection of different colored work pieces and the carrier trays for each piece. I will mention that this model has proven to be a particular favorite among educators I've spoken with who are involved in PLC programming. And the reasoning for that is because it gives students a lot of very specific coding tasks that they have to address. That has to do with the precision of the picker arm and the positioning of the work pieces into the little slots in the storage warehouse. So they do appreciate that fact. And again, it gives students a lot of programming challenges to address. Getting back to the model, the dimensions for this model are approximately 19 by 28.5 by 15 inches. It has a weight of about 18 pounds. Again, the 24-volt version has a relay board for motor polarity reversal in both a multi-pin connector, again, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And again, you need to provide the PLC and the programming. There is a limited release 9-volt version available, which ships pre-wired to a pre-programmed robotics TXT controller. And in that case, one 120-volt power adapter is required. Next up is the multi-processing station with oven. The model you're going to see here features a furnace simulation with a pneumatic sliding door. There is a downstream processing station with a pneumatic transfer unit that includes a vacuum gripper, a cutter with a rotary table, and a conveyor belt. Components used on this model will include 4 mini motors, 6 push-button limit switches, 2 photo transistors, 2 LED light barriers, 4 solenoid valves, and a compressor. The dimensions are approximately 20 by 14 by 12 inches. It has a weight of about 11 pounds. It's again available in both the 24-volt version for use with the PLC of your choice with, once again, a relay board for motor polarity reversal, and both a multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And the 9-volt version in this case is connected to two robotics TXT controllers, so two 120-volt power adapters would be required for operation on that. We'll just let this play through for a minute. And there we go. The next model in our progression is the sorting line with color detection. The simulation model you see here will feature a system for detecting workpieces of different colors, and it sorts them via conveyor belt into 3 different storage areas. Components on this model include 2 mini motors, 5 phototransistors, 5 LED light barriers, 3 solenoid valves, a compressor, and an optical color sensor. The dimensions for the model are approximately 20 by 14 by 12 inches, and it has a weight of about 10 pounds. Now, as before, the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And again, the end user must provide the PLC and the program. The 9-volt version of this model, again, will come pre-wired to a pre-programmed robotics TXT controller, and in that case, one 120-volt power adapter is required. And of course, we'll tell you all about those when we get to that at the end of the presentation. Okay. The next model we're going to look at is the first of the factory simulations. This combines the last 4 models that we've reviewed. In this case, the vacuum gripper robot, the automated high bay warehouse, the multi-processing station with the oven, and the sorting line with color detection. These 4 models are combined into one self-contained material cycle. And the cycle that you're going to see works like this. Work pieces are retrieved from the automated high bay warehouse using the vacuum gripper robot. They're then moved to the multi-processing station with the oven. And after the work piece has been processed by that station, it is then sorted by color in the sorting line with color detection before being again moved by the vacuum gripper robot back to the automated high bay warehouse for storage. Now, as we've already discussed the components of each of these models previously, I'm not going to belabor it by restating them again, but what I do want to mention are the dimensions of this model as a whole. Now, as you again see, it combines 4 individual models into one work cycle, and it's mounted on a board, and because of this, it has a much larger footprint. In this case, it's approximately 39 by 31 by 16 inches, and the weight of this model is going to be between 43 and 46 pounds, depending upon whether we're talking about the 24-volt version or in the case of the 9-volt version, which actually I believe may not be available right now. But the 24-volt is. But anyway, due to these dimensions, please note that this model will only be shipped flat, and it has to be shipped as freight on a pallet. This cannot be shipped regular UPS or FedEx. I also want to point out that as the factory simulation models do tend to be in very high demand for any of the factories, whether it's the plane factories or the factories that involve the IoT connection, there's real high demand, especially during the summer and the early fall. So please anticipate you could have a possible turnaround time of up to 3 weeks prior for any orders for this model leaving our warehouse. Of course, if there's a question, you can call us about that. We can give you more specifics. A few other things to note. First, this is, again, it's available in the 24-volt version. You would have to, of course, have your own PLC and your own programming. When the 9-volt versions are available, and again, I will have to double check on that, it will require 3 120-volt power adapters. And That's pretty much tells you about those. The one other thing I want to mention before we move on to the next group of models is that there is a storage option for anyone who purchases the factory simulations, whether we're talking about the factory simulation model we just looked at, or the models we're going to be looking at as the presentation moves on that incorporate IoT. These travel cases consist of an aluminum case maker profile with plastic plates and steel ball corners, as well as 4 steel tilt angles and angle protection corners. The upper section of each case is partially lined with soft foam blocks in different heights to help cushion the model. And it also has 3 internal zipper pockets for storing cables and other accessories, things like the work pieces and the workpiece tray used with the warehouse and what have you. The lower portion of this case is lined with hard foam, and the way it's designed is so that once the top of the case, the travel case, is removed, that the model can remain in the bottom section and be fully functional. The case has exterior dimensions of approximately 41 by 33 by 17 inches. It has a weight of about 53 pounds empty. So you're looking at probably 100 to 130 pounds once full, depending on which of the variations of the model we're looking at. I also want to note that even when using this travel case, that these models will always need to be shipped flat. So again, you always, if you need to transport the factory models at any point, you always want to ship them flat. You always want to store them flat on a pallet to protect them from any kind of possible damage in transport. The next group of models we're going to look at focus on that area of IoT. So we're going to finally start getting into the Internet of Things. And these are called the Training Factory Industry 4.0 models. And this group of models was designed to help address how the recent changes in industrial production, which were driven by digitization, have of course created a need for stronger networking and more relevant information on all production levels. Now, with this Industry 4.0 update of the existing factory simulation model, such digitization activities can be simulated, learned, and applied on a smaller scale before, of course, they're implemented on a larger scale. Now, as we're lucky enough to have a really nice narrated overview of how the factory works, what I'm going to do is I'm going to step back for a moment and allow you to watch and listen to the narrator. So here we go. Here we go. Oh, wait a second. Why is he silent? Bear with me a second here.
Fischertechnik Learning Factory 4.0
Oh, he's making noise.
Processes for a digitized smart factory, from delivering raw material to the finished product. Industry 4.0 applications can be tested and demonstrated using the simulation model that has already been set up. Digitization activities are simulated on a small scale and learned before they are used on a large scale. The training and simulation model demonstrates the process from the delivery, collection, and storing of the materials through the ordering and the manufacturing processes to delivering the finished product. The training factory industry is controlled by a PLC controller, a Raspberry Pi as IoT gateway, and a TXT controller. The PLC program controls the individual modules of the factory. The program is written in structured text. The PLC communicates via the standard OPC UA protocol with the Raspberry Pi, which acts as an IoT gateway to connect the factory to any cloud. The program on the Raspberry Pi is implemented in Node Red. In Node Red, there is an additional local dashboard available, which can be adapted to your own needs. The Raspberry Pi also communicates with the TXT controller via the standard MQTT protocol, which in turn enables access to the Fischertechnik cloud. The program on the TXT controller is executed in CC++. The sensor image data are used and monitored in the Fischertechnik cloud. The integrated WLAN router transmits factory process data to the cloud in real time. The data is presented on a web-based dashboard. 3 views are available: the customer view, supplier view, and production view. The views and data can be accessed using internet-enabled devices and can also be used remotely. The USB camera is controlled from the cloud and can view the entire factory. A sensor station measures air pressure, air quality, temperature, humidity, and brightness. The default process cycle begins with storing and identifying the material. Using RFID NFC technology ensures that the material can be digitally traced. The integrated NFC tag stores production data that can be read out via the RFID NFC module. The cloud displays the part's color and the ID number. The vacuum gripper places suction on the material and transports it safely to the high bay warehouse. The production view on the dashboard shows where the product is in the manufacturing process. The first-in, first-out principle applies to outsourcing. The goods that were stored first are also the first to be removed. Ordering material is triggered online on the dashboard. The desired product and the corresponding color are selected in the customer view and then placed in the shopping cart. Customer-specific production takes place in lot size 1. The production process is simulated in 2 steps. The suction gripper passes the material on from one step to the next. The material is transferred to the sorting system once production is complete. The sorting system receives the allocation command as soon as the color sorter detects the proper color. The material is sorted using pneumatic cylinders. The production data is written on the material at the end of the production process. The finished product will be provided for collection. Instructional material and the source code for the stored programs are available online. The fischertechnik Learning Factory 4.0 is ideally suited for education and training in vocational schools and companies, for research and teaching in colleges and universities, for development projects in IT departments, for production planners, and for demonstrating in-house software solutions at trade shows and other corporate events. The customized storage and transport case is a worthwhile add-on.
Okay, so just to summarize things very quickly, here are some of the topics which can be addressed with the fischertechnik Training Factory Industry 4.0. Of course, training and simulation on a realistic production model, in-depth learning through haptic comprehension, optical and sensory applications, digital traceability with NFC/RFID technology, customized production in lot size 1, integrated cloud connection and control via smart devices, using and operating dashboards, web-based remote maintenance, the linking of production materials planning data, connection of upstream and downstream logistics processes, and for experts, the creation of your own unique programming using C, C++. Now, as you just saw, the model incorporates many features that aren't found in the models that we talked about earlier, perhaps most notably being the use of the cloud-based dashboard for monitoring and controlling the model. Some other examples would be the camera that's used for visually monitoring the factory functions from the cloud-based dashboard, as well as the environmental sensor, which collects data on variables such as temperature, air quality, humidity, and air pressure. The use of NFC chips in each workpiece enables the positions of each workpiece in the work cycle to be mapped, and the use of MQTT, or message queuing telemetry transport, that allows the network TXT controllers to communicate with one another. Now, in regards to the 24-volt version specifically, hang on a second, there we go. I should note that it's a bit of a hybrid in that while using a PLC for operation and control, it also incorporates one Fischer Technic's robotics TXT controller. The TXT controller serves as the MQTT broker and interface to the Fischer Technic cloud, and communication via the PLC and TXT controller is carried out using an IoT gateway via OPC UA, also known as OPC Unified Architecture, which is the standard for exchanging data across different platforms. Now, in addition to the TXT controller here, there's also an IoT gateway using Raspberry Pi with Node-RED. And this allows the option for not only presenting and using data on a dashboard in Fischer Technic Cloud, but also to be able to display data and calibrate the stations of the factory in a Node-RED dashboard. The model also incorporates newly developed 24-volt adapter boards to interface to the PLC, and these, of course, ship as part of the assembled training factory and are connected to the PLC via terminals. Now, among other things, the latest generation of adapter boards allows for the speed of the encoder motors to be controlled via PWM or pulse width modulation. And they also have push-pull output stages for phototransistors and for buttons. Now, unlike the previous 24-volt models that we've discussed today, the new 24-volt Training Factory Industry 4.0 includes access to a sample program. This is big. The program, which was created in structured text format, was created based around a Siemens S7 1500 PLC, and this programming is available for download on GitHub. You could even go and download that right now. You can go to the Fischer Technic website and find the link to that. You can download that. We're happy to help you out with that. Of course, the new training factory could also be controlled with other PLC models or other brands once the end user makes some adjustments to the sample program, and the source code that you would use for that is also available on GitHub. Now, all of this information and much more is included in the 152-page PDF manual, which can be downloaded from the Fischer Technic website and which is available from us upon request. So again, you're going to get some email addresses in a few minutes if you'd like to get access to the manual for this or a couple of the other models we're going to be discussing. You can feel free to email me, let me know what you're looking for, and we'll get those sent off to you. Now, I also need to mention that as of last year, there are 2 additional versions of this 24-volt model which are available, and we're going to discuss those when we get to the overview of the costs of each model in just a minute or two. Now, in the case of the 9-volt version, the control is facilitated through the use of 6 robotics TXT controllers. Again, in the case of the 9-volt model, all of the programming is preloaded, so that once connections to the internet and the cloud-based dashboard are made, all of which are clearly outlined in the downloadable documentation PDF, once that's done, you should be able to get started very quickly. The 9-volt version will require the addition of 3 120-volt power adapters. And again, while it should go without saying, whether we're talking about the 9-volt or the 24-volt version, it's also required that the end user, of course, has the ability to access the internet for the cloud-based dashboard, as well as some sort of a tablet or device for getting the dashboard to appear on. So you need that. You need access to the internet. You need some sort of a device. That's a given, but I like to mention it. Also, to finish things up, the dimensions for these models are approximately 39 by 31 by 16 inches. They have a weight of between 51 to 53 pounds, depending on which version we're talking about. And in either case, we do recommend the optional travel case to help protect your model during transport or during storage. And that essentially is the Training Factory Industry 4.0 model, again available in both a 9-volt and a 24-volt variation. Now, the next model we're going to talk about was just added to the Fischer Technic simulation line in late spring of 2023. And this model, the new quality control with AI, incorporates the cutting-edge technology that's quickly becoming a part of our daily lives. Now, this model is ideal for visualizing this complex subject area in a hands-on manner as it creates a sustainable learning experience by linking theory and practice. Processes can be sped up, fault rates and costs minimized, and fault evaluation can be standardized. This Fischer Technic sorting line comes with workpieces in 3 different colors, as you see, but these workpieces are marked with 3 different processing characteristics as well as various fault patterns. The workpieces are scanned by the camera, and then classified with the aid of the trained AI. Now, depending on the color, the feature, and the fault pattern shown on the piece, the work pieces are then sorted by the artificial intelligence on the basis of the quality features. The AI used is realized with machine learning in TensorFlow, where an artificial neuronal network was trained with image data. The learned AI is executed on the fischertechnik TXT 4.0 controller. The model sequence is implemented in the RoboPro coding environment and in Python. Now, if you want to go a step further, you do have the option of generating your own AI applications. And in this case, the training is done in Python, for which a sample project is provided for explanation. And that essentially is the quality control with AI model. It's ideal for training, simulation, and demonstration. It's great for education and research and for the visualization of AI systems, for machine learning and neural networks. Right now, it's available only in a 9-volt variation with a 24-volt version anticipated for release later in 2024. I will mention that the 9-volt version uses the fischertechnik's Robotics TXT 4.0 controller, and as before, one 120-volt power adapter is required for the operation. Next model we're going to look at has just been released. It was literally released about a month and a half ago, and this is the Agile Production Simulation model, which is the very latest iteration of the factory model. This time, not only incorporating IoT and state-of-the-art manufacturing processes, but also AI, and this time with a digital learning platform included as well. Now, the factory of the future that you're going to see here is the subject of numerous research projects in science and industry. Forward-thinking companies rely, of course, on automation, modularity, artificial intelligence, and agility, all to remain competitive. Now, in order to promote these topics in industry and research, students, apprentices, and even employees require the corresponding know-how and awareness to deal with these complex issues. And that's where the learning concept Agile Production Simulation comes in. What this does is it simulates processes such as quality assurance using artificial intelligence. It includes the functioning of driverless transport systems, and it replicates automated processes on a small scale, from goods receipt, modular production, to quality assurance. The accompanying learning materials translate the hands-on simulated processes into future skills for both students and for teachers. And the digital twin of the model significantly intensifies the learning experience. Now, as we don't yet have the narrated video of this brand new model, we're expecting it any time. So hopefully the next time you might, if you chose to attend this webinar again, we should have that in place. But for right now, I'm just going to provide you with a quick overview, beginning with the module where incoming and outgoing goods are placed. And this would, of course, be where the material flow of a work piece begins and ends. The raw material is delivered at the goods receipt slot, positioned on the color sensor for quality control using the 6-axis robot with a vacuum gripper. Keep in mind, this is a 6-axis robot now. This is also a new variation. And then encoded on the NFC reader. The robot then places the workpiece on the automated guided vehicle, which we'll refer to as the AGV moving forward, for further transport. The module also contains the central control unit, in this case a Raspberry Pi, and the environmental sensor, which measures the different environmental conditions in the factory. There's also an integrated movable camera, which can be swiveled in 2 axes and provides an insight into the entire factory via the fischertechnik cloud-based dashboard, which we saw an example of in the previous factory video. Now, at the end of a cycle, a finished workpiece is delivered at the goods dispatch by the AGV. The next stop for a workpiece after goods receipt is usually the high bay warehouse. Although, because this is an agile production simulation, that could be switched up. But in any case, the high bay warehouse contains 9 slots for workpieces. It has a stacker crane, a vacuum gripper that picks up the workpiece from the AGV at the docking station and hands it over to the stacker crane for storage. The workpiece is placed in a workpiece carrier for storage, and retrieval of the piece is done according to the FIFO, first in, first out principle. I will mention too, if you're looking at this, if you've been paying attention, This is a different variation of the high bay warehouse than you would have seen earlier in the presentation, and a different variation of this model than you would see used in the other factory models. So it's not the same at all. Next up, we have the drilling station, which consists of a docking station for the AGV and a vacuum gripper that places the workpiece onto a conveyor belt from where it is transported under the drilling head. Now, after the simulated drilling process takes place, the workpiece is transported back to the gripper on the conveyor belt, and the gripper then places it back onto the AGV. Next up is the milling station. The milling station consists of a docking station for the AGV and a vacuum gripper that places the workpiece onto a conveyor belt from where it is transported under the milling machine. There, the milling of two pockets is simulated. Now, after this simulated process, the workpiece is placed back onto the conveyor belt and then transported back to the gripper. The gripper then places it back onto the automated guided vehicle. Now, in the quality assurance module, which is the next one we're looking at here, a vacuum gripper places the workpiece on a conveyor belt. It is transported underneath the camera and it's scanned there. The workpieces, which come in 3 different colors, again, red, white, and blue, with 3 machining features, drilling, milling, or a combination of drilling and milling, as well as various fault patterns, are all classified using the trained AI. Now, depending on the color, the feature, and the fault pattern, the workpieces that are in either placed back onto the AGV as being okay, acceptable goods, or sent to the reject container as not okay, or, of course, defective. The AGV then transports the workpieces from one module to another. It is a track-bound vehicle that follows the printed black tracks on the base of the model. It uses ultrasonic sensors to detect obstacles. The vehicle itself has omni wheels, which allow it to move in all directions. 2 buttons and a photo transistor help the vehicle dock to individual factory modules. The AGV receives its driving commands from the central control unit, an industry standard VDE 5050, and it uses a fischertechnik rechargeable battery pack as its power supply. And speaking of the battery pack, when the battery of the AGV runs low, it navigates toward the charging dock, where it is automatically charged with a charger with charge monitoring. Contacts on the bottom of the charging station connect the AGV with the charging electronics. Just to give you a couple of the specifics, a power supply is a 24-volt power supply, unit 11 amps. Central control is Raspberry Pi 4B. The individual module control is 5 SPS Siemens S7 1200. So in this case, you have 5 SPS Siemens S7 1200 PLCs are included with this. There are also 3 TXT 4.0 controllers included for the sensors in the camera, as well as cloud access and the WEWA module for quality assurance with AI for automated guided vehicles. There's a WLAN router for WLAN network. Software is the SPS program and structured text. There's TypeScript for central control of the Raspberry Pi. There's Node-RED for communications between the SPS and TXT 4.0 controller. Pythons for programs on the TXT 4.0 controller, and TensorFlow for supervised learning and quality assurance with AI on that module. Again, there is also a digital learning platform with a digital twin of the APS model, so that learning can be done with both the actual model as well as in a virtual environment. And again, we're going to have more details on this as well as other aspects of this new model, along with a video overview of the model in action available soon in a separate presentation, which we hope to announce very shortly. But for now, this at least gives you an overview of the Agile production simulation. Of course, at this point, we've shown you a lot of things. You might well be wondering, so how much do these models cost? So we're going to take a quick review of each of the models, except this time we're going to give you the pricing for them. So we're going to begin with the conveyor belt. It's available in 2 variations right now. The 24-volt version for use with PLC is $354.95. The 9-volt version that includes the robotics TXT controller pre-programmed is $518.95. The punching machine with conveyor belt in the 24-volt version requires PLC in the programming. It's $464.95. The 9-volt version, including the TXT controller pre-programmed, is $599.95. The indexed line with 2 machining stations, the 24-volt version, $1,199.95, again requires PLC and programming. The 9-volt version, I believe that again includes 2 TXT controllers, requires the power supplies. It's $1,394.95. 3D or 3-axis robot in the 24-volt version is $1,059.95. The 9-volt version is $1,369.95. The vacuum gripper robot, only available in the 24-volt version, is $1,199.95. Of course, requires PLC and programming, as most of the 24 volts do. The automated high bay warehouse in the 24-volt version is $1,448.95, requires PLC and programming. The 9-volt version is $1,318.95, very limited, so if that's something you're interested in, let us know soon. The multi-processing station with oven, the 24-volt version, is $1,287.95. The 9-volt version is $1,474.95. Again, the 9-volt includes the TXT controller. The 24-volt requires the PLC. Sorting line with color detection in the 24-volt version, requiring PLC and programming, again, $1,126.95. The 9-volt version with the TXT controller is $1,128.95. The factory simulation, yes, only available in the 24-volt version right now for the regular factory simulation. The 24-volt version, again, requires the PLC and the programming that you have to provide. That is $5,149.95. The Training Factory Industry 4.0. In the 24-volt version, which again requires the PLC, you have the sample program. That's $9,498.95. The 9-volt version, again, that's going to be moving to a new part number. You see 2 part numbers listed there. That is $9,498.95. That's pre-wired to the TXT controllers. Now, there is a new Training Factory Industry 4.0 that has a PLC connector board in the cabling. So this is a variation that includes everything you need besides the PLC, so that you can basically get this hooked up to, easily enough. This saves you a lot of time and effort in doing the wiring, makes it a lot easier. This version is $12,718.95. Again, this is the 24-volt version. Then there is another version. This one includes the Siemens S7 1500 PLC. So this includes the wiring, the control board, or the connection board, I should say, the PLC, what you see here. In an education version, this is only available for accredited institutions, universities, colleges. You're looking at $19,319.95. The commercial version for any industrial users, anyone who's not education, you're looking at $20,124.95. And that again includes the program, and in this case includes the PLC. So just to review, the PLC connector board version, where you add your own PLC, that's $12,718.95. And if you get the version with the Siemens PLC S7 1500 included, if you're in the educational sector, you can purchase that for $19,319.95. And if you're a commercial user, that would be $20,124.95. Other items. The 120-volt power adapters that I mentioned throughout the presentation, those are $12.99 each. Those are needed for, of course, the 9-volt models, in some cases needed for a couple of the 24-volt models. The travel and storage case, this is for all of the factory simulation and Training Factory Industry 4.0 models that we've looked at so far. Those are $1,524.95 each. The quality control with AI model that we looked at, again, only available in the 9-volt version right now with the TXT controller pre-programmed. That is $2,249.95. 24-volt version, we hope to be available later this year. So we'll keep you posted on that. Finally, the Agile Production Simulation Model. This is available in the 24-volt version only. Again, this comes with 5 Siemens S7 1200 PLCs and 3 TXT 4.0 controllers, and it also includes a digital twin to work with. The cost for this is $28,174.95. Very hot model right now. Again, this was just released about a month and a half ago. Very high demand, very exciting model. We're very happy about this one. There is a special storage case for the Agile production simulation because it's a much bigger model. It's a modular model. It requires a different type of case. The case for this 2 tiers is $4,024.95, as you see here. And we'll just take a look at some of the photos of how this model breaks down here. You can see it's the different sections come apart. They can be stored separately. So on that note, you've stuck around a long time. If you have any questions, again, I would ask you use either the question and answer window or the webinar chat window that can be found on the toolbar. If not, I'm going to go once, go twice if I don't see anything coming up. I'm going to tell you how to take the next step. So if you would like to request a full color brochure and current pricing, anything else that I mentioned throughout the presentation that I said that you could get access to, if you'd like to ask us any questions directly, if you'd like to request a quote, or if you would like to speak with your dedicated educational representative, in any case, you can call us. Our number toll free is 888-561-7521. That's Studica here in the US. We are a 9 a.m. to 5 p.m. Monday through Friday Eastern Standard Time company, so please call within those hours. You can email us with any general inquiries, questions, asking for catalogs, quotes, what have you. You can email us at info@studica.com. If you have any questions that you want me to answer specifically, either about anything that I spoke about today, promised today, any questions you may have about any aspect of these models or anything else fischertechnik related, you could also email me directly. My email, of course, is lance.zurek, lance.zurek@studica.com. So on that note, I'd like to thank you again for taking the time to attend today's presentation. Have a great afternoon. We look forward to hearing from you soon. Take care.